Hi, welcome back to another video of this learning C++ journey. So until now we have completed 9 lessons. So this lesson 10 is going to be all about the inheritance, the one of the pillars of 4 pillars of object oriented programming. So let's start with the simple definition of inheritance. So basically what inheritance means, so it actually demonstrates the concept or is a relationship. So is a relationship. Okay, so what inheritance represent? It represent is a relationship. For example, if I tell you Shahir is my name, so Shahir is a human. So this is a relationship. Okay, now if I say mango is a fruit, this is a relationship. I say civic is a car. So all of these examples demonstrate the is a relationship. These are the examples of the is a relationship. So basically, in simple words, the inheritance concept is also this concept. So basically what happens in inheritance, that we design a parent class or a base class. You will call it a base class or someone will call it a parent class. Both terminologies are used interchangeably. Okay, so here is one parent class or one base class which has the qualities that all its child class or derived class. Okay, child and derived are used interchangeably. Child or derived class will have, for example, if I have a main class, base class, or a parent class as a human, then a child class can be a male or female. Okay, so these can be two child classes. Now within those two child classes, it can further be distributed. We will learn those things in a multi-level or multiple inheritance as well. Just for now, just understand the concept of inheritance. So what actually inheritance means, it demonstrates the is a relationship. So this is the examples of is a relationship, that we have some type of a parent class, or we can call it a base class or a main class, from which the derived class, the children class, the child class takes the attributes. Okay, so for example, let me give you an example that now I will show you a simple example, a simplest example, with the help of which you guys will get the idea of inheritance. So for example, if I have a class as human, okay, I will call it human. Now I have a human class. Within human, I have some members. I can have 3 types of access specifiers. You guys already know. I have private, I have public, I can have a protected as well. The private members, the private attributes cannot be accessed outside the class. Okay, so this means that if a certain human, if a certain main class, if a certain parent class has such qualities, has such attributes that cannot be inherited into another child class or any other class, that means those attributes will remain in the private section. One thing. Another thing, let's say we have some things, we have some attributes that we want to inherit, that we want to include, that we want to access from another class, from another derived class, that is the derived class of this human. We will use this protected section. Or if we want such attribute that anyone can access it, anyone can access it directly and set its value directly, we will keep it in public section. So that means that if we want to inherit some of the qualities, attributes, or member functions of our parent class or our base class, we would be using these two access specifiers, public and protected. Private members cannot be accessed in a derived class as well. So this is the one thing that you guys should know. So now back to the example. What we are going to use, we are going to use protected in this case. So In protected, I will write an example. Let's say that I have attribute string gender. Okay, every human has a gender. Then I will write human, let's say, name. Okay, then string, I will write um, its height, let's say. So these are some qualities. Let's say these are some characteristics of a normal human being. Now let's talk about some functions. Every human will sleep. So let's say we have a function sleep. See out sleeping. Okay. So we have a function of sleep. Now let's have a function void eat. Every human he eats as well. Now as you guys can see, these are some common qualities of each and every human. Okay, sleeping, eating, and any other example as well. So these are just for the demonstration purpose. Now every human has its own gender, every human has its own name, every human has its own height. Now every human can sleep as well, every human can eat as well, and there are lots and lots of qualities and attributes of each and every human. Okay, now let's talk about inheritance. So let's say if I have a class, if I have a derived class, so what is the syntax for the derived class? So first of all, you will write the name of the class just in a normal way. Let's say I want to have a derived class as male. Okay, now I have a derived class as male, then I will write this single colon, then I will write the access specifier name. Now here is the concept of access specifier in the derived class. For example, for now I will just write public just for the simplicity of understanding, and then I will write the name of the class. So the class name is human. Okay, and then we will have these curl brackets. Okay, so these brackets are not here. Okay, sorry for this syntax mistake. Now let's say I am not writing anything, this will remain empty. Now as you guys can see that I haven't wrote any lines of code in my male class, but still when I get to my what is called, it's the derived class, I will write here the derived class, derived or child class. Okay, you can call these both terminologies can be used. So if I write over here, let's say if I write gender, so as you guys can see, I got the variable name gender without even declaring it within this class. So that means that these qualities, the gender has been inherited in this derived class. Now I will write gender is equals to male. Okay. Now I will write height, let's say height is equals to 5.7. Okay, then I will write, okay, the height should be float, I guess, not. Okay, the name would be, let's say, name would be Shahir. Let's say I have my name Shahir. Then after that we have a lot of functions. Now within main function, if I write C out, and if I write first of all, if I declare anything, like if I declare male, I'll say male, and I say m1 means male 1, and if I print m1 dot, as you guys can see that you have got the access to all the members of the parent class, eat, gender, height, name, sleep, and none of them have been declared within this class. So if I remove all of these things from here, still you would be able to access them, okay, in the main class, on a condition if they are public. Okay, because protected can only be accessed in a derived class. So now it can be accessed from our main class. Now as you guys can see that we have got eat, gender, height, name, sleep, and none of them have been declared within this male class, which is the derived class of our human class. So this is the basic concept, and this is the basic understanding and purpose of the inheritance, that we inherit some of the qualities, we inherit the qualities and attributes of another parent class or base class on the basis of is a relationship. Now male is a human, that's why we can inherit, we can design a child class and we can inherit all the qualities of a normal human into this male class. So this is the basic concept of the inheritance, with the help of which you will not have to write the code again and again. Instead you can just inherit these things and you will be good to go. Now if I tell you that if there was no inheritance concept, let's say if we didn't have this inheritance concept, and if I were to design the male class, so what I had to do, for example, I had to have all of these qualities in my uh, male class. Okay, so I'll just paste it over here. Now as you guys can see, the code gets lengthier. Now the code is 2 times the previous code. One is the length has increased. Another, the complexity has increased. How the complexity? The code complexity has increased because now you have to write all of the things. If I want to write, let's say if I want to have class female, now I have to rewrite all of these qualities, all of these attributes again in my female class as well. So instead of that, we have an easy approach. We have a approach that is called inheritance, which is based on is a relationship. Now there can be plenty of examples. For example, we can have a example of fruits. We can have a example of cars. We can have examples of any other. So let me give you some more examples. We covered the human example. Let's say if we have fruit, let's say fruit. Now every fruit has some sort of quality or some sort of member variable that is common. For example, every fruit must have a color. Okay, every fruit must have a name, every fruit must have a taste. Okay, so all of these attributes are common among all the fruits. Now they can be different in any way, like someone will taste bitter, someone will taste sweet, maybe some has the name mango, some has the name orange, and some has the color yellow, some has the color orange, some has the color red. Those can be different, but the member variable names remain the same. So instead of writing the color, the name, the test, all the member variables again in my mango class or orange class, instead I can just inherit all the qualities from the fruit class, and I will just assign the values in my respective derived class. So this is how the inheritance makes your code more easy and makes your code more readable and makes your coding life much simpler and easier. So with the help of inheritance, you can organize your code in a very good manner. Now let's talk about access specifiers in our inheritance classes. Okay, so for example, let's have a look. Let's have class, and I will call this class as parent class or maybe base class. Okay, let's say base class. So I have a class called base class. Now let's have some members. So I will have private member. I will call this as integer private. Okay, so instead of whole keyword private, I will just write pri. Okay, so I have got pri. Then after that, I will have protected. So this is just an example to show you the access specifier functionality in inheritance. Okay, protected members. Now let's have a pro. Okay, I have a protected member. Then I will have a public member. Okay, integer pub. Now, as you guys can see, I have three member variables. One is in private section, another one is in protected section, and another one is in public section. Now, what I am going to do, I am going to show you that how can you access them and whether if you can access them or not in your derived class as well. So you guys already know that what is the concept of the private section. In private section, whatever you have declared or defined, like a member variable or any member function, they cannot be accessed outside the class. So if I write pri in my derived class, I cannot have it. So I'll write class, and the syntax is dr is this single colon, and then you will write the public keyword. So first of all, I'm not touching this concept right now. First of all, let's clear this one out. Then after that, I will tell you about this access specifier. Okay, so first of all, clear this concept. After that, we will talk about this. Okay, so for now, just ignore this public keyword. Then after that, we will write the base class name. Okay, so I've got the base class name. Okay, all right. So now let's have some values. Let's put some values into these guys. Okay, equals to 1, just in order to see what they print. Otherwise, it will print some random data. Okay. Now let's say I have a function. I have a function as a print function. Print, not print f, but print function, void print function, in which I want to, if I can print data, that means I can access data. So that's why I'm designing a print function. So I'll write cout. Now let's try to print this private integer. Okay, so I'll write p, okay, pri. Do you get anything? So there is a red mark over here. Okay, let's see and call this function and del. Okay, so I've got a what I'm trying, that I'm trying to print this pri variable in this print function. So now let's design a derived class object. So all the remaining syntax remain the same. You have to declare an object, you have to declare a class with the data type name as your class name. So derived is your class name, and in front of it you will write the object name. So let's say d1. So this is the simple syntax. Now first of all, what I am going to write is that I'll write d1 dot print. So as you guys can see that print is marked as red. Why? Because as you guys remember, I told you in the tutorial of class that whenever you want to access something outside the class, you have to put it in the public section. Now this print function right now by default it is in private section. So what I have to do, I have to write the public keyword in order to access. Okay, now it's in public section and I can access. As you guys can see, it is now green. Now let's try to print. Let's try to understand the concept that I wanted to tell you. Now let's run this program. Something happened, nothing. But here is an error, in which I told you earlier, just to observe. Observe, integer base pri is private within this context. That means it shows that anything that has been declared in the private section cannot be accessed in your derived class. This is one concept. You got the idea? Try it for yourself as well. Okay. So this is member variable. The same behavior will be for member functions or any other kind of attribute that has been declared or assigned or initialized within the private section. Now let's talk about protected. Now let's try to print PRO. So I'll say PRO. Now let's run program and it is going to be without an error. Okay. So as you guys can see, we have got the value of PRO. So that means that we can access PRO in our derived class. But wait, you guys will say that this is going to be the same behavior for public. Nope, there is a difference. Let's have a look. But first of all, before moving to that difference, I'll tell you about public as well. Let's demonstrate the public concept. After that, we will see the difference between these two. Okay, let's try. Let's go. Okay, so I'll write here pub. Okay, pub, because it is in public, and obviously it is going to be without an error because public can be accessed as well. So as you guys can see, up until now you'll say, okay, all right, public, protected, whatever, we got the access for both of those sections. Nope, there is a difference. Now let's see what is the difference. Here is the thing. What we were doing, that we were accessing the function in the public section, and with the help of which we were printing the protected member as well as a public member. This is the same concept as we used in our previous classes tutorials. Now, if I want to access something from main directly, so this is the word directly accessing a member variable. As you guys remember, I told you in the beginning that we will be studying protected in much more detail. So here is the study of protected. Okay, so if you write d1 dot something, like this is the notation to access the members of the class. So if I write dot, and if I try to print or access d1.pro, so let's print d1.pro, see out. Okay, so I'm now trying to access the d1.pro, which means the protected member of our main class that has been inherited into this class. Now let's print it. Yes, it cannot be printed. That shows us that we cannot access protected members outside any derived class. So if I have a keyword as base, then I can access it only in this derived class, but not in any other function outside this class. So as you guys can see, integer base pro is protected within this context. Now if I write pub, which means public, I can easily access it, I can modify it, I can print it, I can do whatever I want. So this was the concept of private, protected, and public access specifiers in our base class and its behavior with our derived class. I hope you guys got the idea of access specifiers and how they act in our base class and whenever it is used in our derived class. And this is how it all works, how all the access specifier works whenever you are using inheritance concept. Now, as I told you that I am going to show you the concept of this keyword, the access specifier used with derived class. Now, we got the idea of the base class. Now, let's talk about our derived class. Now, we have some keywords. Now this keyword represents the data that has been inherited from the base class. For example, in this example, as you guys can see that I have got 3 member variables in my base class. So no access, yes access, yes all. Okay. So no means it cannot be accessed outside the main class. Yes means that it can be only accessed outside the class, but in the derived class, yes all means that it can be accessed anywhere. Okay, if you have a declared object, you can access them. Second thing, here is this keyword that public I'm using. This is the same concept. But this concept, this keyword, the access specifier used here before the name of the class, that is only applicable on these member variables in this class. Okay, it sounds difficult, but don't get worried. Okay, let's go understand this concept, okay, with a demonstration. All right, let's understand the behavior of a access specifier here when it is used before any base class. Okay, so let's try to put all of these things within our private section. Okay, so let me ask you a question. All of these things are right now under this private keyword. Will it be accessed in outside the class? or in the main function or any other function? The answer is no. One concept is clear. So what we are going to do, we have two options. Either we are going to use the keyword of public, or either we are going to use the keyword of protected. So let's start with the public. Okay, let's keep each and everything public. Now, if each and everything is public, that means that you can access it in the derived class as well as anywhere in the functions as well. So that is clear. This is just a simple concept. So you can access PRI, PRO, PUB, all of them. Okay, 1, 2, 3, all of them can be accessed. Now, let's talk about this access specifier. So if I write this public keyword, that means that all of these qualities that has been inherited. Now, for example, if I have a class like, if I write the keyword, no keyword over here, and if I don't write any code, I will remove all of the code from this class. Now, if I use public, that means each and everything quality that has been inherited from the base class is open to public. Okay, so empty class, but I have inherited all the qualities with the help of this code. Now if I write cout d1 dot, I can have, as you guys can see that I have got green, green, green. That means I can access PRI as well as a cout d1 dot PRO and del cout d1 dot public. Okay, so let's print all of them. So as you guys can see that I was able to print all of the data, okay, all of the data. Now I have nothing within my class. And as I told you in my class tutorial that whenever I don't write any keyword in my class, everything by default gets in under the section of private access specifier. But here I am not writing any keyword, but I am still able to access all the qualities of my derived class. What was the reason? The reason was this access specifier keyword. This access specifier keyword shows you the behavior going to be of the members that has been inherited, that have been inherited from the base class. So which means that if I write protected here, let's say if I write protected here, that means that now I cannot access all of these values, because they have been protected. They have been under the word of protected in this base class. Okay, and I cannot access is outside the class. Okay, so it cannot be accessed as expected. Now if I write the private keyword, obviously we are not going to get the access for these member variables. So I hope you guys got the basic idea of access specifier used before the name of the base class, that it tells you the behavior going to be the qualities that has been inherited from the base class. Now if I write the public keyword over here, protected keyword, I can inherit all of these qualities in my base class, but all of them will remain in private section, and hence I cannot access them outside the class. But instead I can do that in my void print function. Okay, and if I write over here, then I can do that. If I write d1 dot print, okay, oh, okay, and I'll just write this as in public. The print functions must be in public. Okay, what's the reason d1 was not declared in this scope? Oh, sorry. Whenever you are working within the object, you should not have the object declared name. You will just write the member variable name. This is the same concept. And as you guys can see, I've got a 1, 2, 3 on my output screen. So this was the concept of our access specifiers that is used within the base class and that is used with the base class name before when you are declaring a derived class. Now let's conclude this today's lecture. Let's conclude it in just simple words. Let's conclude it. For example, if I have, let's say if I have something in my base class, so in private section, they cannot be accessed, can't be accessed outside class, outside base class. Okay, if I have a keyword protected within my base class, can be accessed outside base class but only in derived class. Okay, now if I have a keyword public, can be accessed from anywhere. Got my point? So this is the story for our base class. Now let's talk about the story for the when we inherit members from our base class. So if I have a private, when I have private inheritance, this will demonstrate the same behavior as in normal classes. Private member. Okay, what does it mean? It means that it will keep all of the inherited qualities in private sections, hence they cannot be accessed outside the class. So this will demonstrate the same behavior as in normal classes private members. Now if I do the protected inheritance, this will demonstrate the same behavior as in normal classes protected member. Okay, now if I have something public inheritance, this will demonstrate the concept of a public as in normal routine. Okay, so what does these short notes mean? This tells us that whenever we do private inheritance, this will demonstrate the same behavior as in normal classes private member, which tells us that private inherited attributes or member functions. Okay, so this is the case for the private, and if I do protected, it will keep each and everything in protected. So I'll write protected, and the same thing for here is a copy and paste, and what we are going to get in case of public, we will write it as public this. And so you got my point. I hope so. You got the basic concept of inheritance, and from the following the next tutorials we will put all of these concepts into practice with some example, with some practice problem, and hopefully building a good project as well. So these notes will help you if you want to take a screenshot, if you want to write them, you can do it. So just this. Okay, so remember the behavior of all these data members. Okay, so the concepts are still same. Don't get very about access specifier used whenever you want. Just remember what each access specifier means. Private means can't be accessed outside the class. Protected means can be accessed in the derived class. Public means it can be accessed anywhere. This is the same concept and it is applicable everywhere whenever you use them, okay, and wherever you use them. Okay, all right, this video was lengthy. I don't know whoever made it, but if you have made it, give it a like and let me know in the comments. Okay, bye, and I'll meet you guys in the next video.